So here we are again, day 3. Well, actually day 4, I suppose, of 7 of our circles, a module 7 here. Hopefully you've been able to keep up a little bit with what we're doing. We're going to add a couple of new little properties today. In and of themselves, they're pretty simple, but you'll see some of the problems here that we work on when they start getting a little more involved can be a little tricky, but not too bad. So review a little bit, central angle, inscribed angle. We went back to 7071. We just did some vocabulary stuff, made sure we understood what that meant. Think about the center of a circle. In this case, it's C. If we were to draw out 2 radii to intersect our circle, this angle is created from the center by those 2 radii. So that's a central angle. Okay. So our central angle is what we would say is angle ACB. So remember, the vertex is C. That has to always be in the middle. When we draw that in, what that creates is arc, and this little symbol on top is AB. So the central angle drawn between AC to B creates an arc AB, and that arc would be this little guy here, and it's specifically a minor arc. That's why we only use 2 letters to define that. So the property you're going to want to understand out of this little drawing here that we're going to use for our problems is that a central angle is always equal to, central angle always equals the degree measure of the intercepted arc. So long story short, if this angle here is, let's say, 30 degrees, then this arc takes up 30 degrees of the full 360 around the circle. So whatever the arc is, the intercepted arc of a central angle, it's the same degree measure as the angle itself. All right, and that's what you'll see quite often here as we work through this, and then the assignment that I would leave, and then a quiz whenever we get to it. So an inscribed angle, if we review what that meant, that is an angle that is created by a point that's on our circle. So this is actually on the circle, this vertex. And then we were to draw what we called a chord out to A, and then a chord out to B. So this is our inscribed angle. I didn't name this. Well, we'll say it's angle 1. So our inscribed angle is angle 1. It creates the arc AB as well, from here to here. And what you want to understand about this is that whatever angle 1 is, so our inscribed angle is always 1/2 of the intercepted, I spelled that wrong, intercepted arc. So what that means in simple terms is, let's say this angle was 20 degrees. That means this angle is half of the intercepted arc. So if this is 1/2 of this arc, that tells us this arc must be 40 degrees. All right. Or let's say I did it the opposite way. Let's say I instead gave you the arc, and let's say the arc, let's in this case say this is 60. That would allow us to know that angle 1 would have to be 30, because this angle is always half of the arc. Okay. Same here. If this, so here's our inscribed angle. It's a vertex on the circle, and then we create an angle out of this. Whatever this arc is here, so let's say that uses up, let's say maybe 160 degrees of the full 360 all the way around our circle. That's 160. Then we would know that this angle is always the intercepted angle is always, or inscribed angle, sorry, is always 1/2 of the intercepted arc. So this is the arc that's created by that angle. This has to be 1/2. So this would be 80 degrees versus the 160. So always half of the arc. Okay, so little examples that will kind of show what that gives you. You are told here that this would be read as the measure. This is our arc symbol. The measure of arc MK. And since we're using 2 letters, we know it's the small one. It means we're not going all the way around. It's the short, direct, most direct path from M to K. And you were told that this is 48 degrees. This is an inscribed angle that's created here, angle L. And what we just said is an inscribed angle is always 1/2 of the intercepted arc. So if this arc was 48, this angle would have to be half of that. So 24. So this is 24 degrees. Okay. Number 2, also an inscribed angle because the angle itself lies on the circle. And then that angle is going from here to here. You are then told that arc CO, so from here to here, is 150 degrees of the full 360. Well, think about what our intercepted arc is. So if you think about this angle, COE, the intercepted arc, let me try this in gray, created by that. No, let's not do that. Let's do yellow. Is going to be big though. This is the intercepted arc by this angle COE. What we know is the entire circle is 360 degrees. If we subtract away the part that we know, which is 150 degrees, what that tells us is the yellow part would have to be a total of 210 degrees. So that when we add the 150 along with this yellow part, the 210, we add up to be 360 degrees, like we know a full circle is always going to have. All right, so if we're ultimately looking for our angle, COE, this angle here has to be half of the intercepted arc, which is 210. So this angle must be 105 degrees. Okay. All right, 3, you're told the measure of arc JI. So the minor arc JI is here. That's 50 degrees. You were told that segment JU is parallel to segment IE. So here is the segment JU that is parallel to the segment IE. We want you to find the measure of arc JU. All right. So as we kind of look at this, couple of things. You got to remember some old rules here. The fact that these guys are parallel tells us that our alternate interior angles are congruent, things like that. But what it also tells us then, if these are going to be congruent, these are going to be congruent, that the inscribed angle, so angle U to J in here would have to be 25 degrees. And since these are alternate interior, this angle has to be congruent to this angle. So this angle here must also be 25 degrees. And then if you look, this is an inscribed angle that creates this intercepted arc, UE. So we would know this would have to be 50 degrees. What we're ultimately looking for is here, the J to U. So what we would have to understand is, notice what this segment is here. This is our diameter. It cuts our circle in half. So 360 degrees around a full circle. This goes right through our radius. So if we divide this by half, we would know this anyway, 180 degrees. So what that means is, from here all the way around to here must be 180 degrees of our circle. So we have 50 here, so we get rid of that 50. We have 50 of it over here as well. Let's get rid of that 50. Whatever the remaining part is would have to be the part that we are looking for, which is JU. So this would have to be 80 degrees. Okay, so the measure of arc JU, 80 degrees. All right, so you'll see here, you really got to understand these rules and be able to kind of make some connections. They're not these super quick all the time anyway. The first couple were, but you really got to be able to think a little bit and problem solve. Okay. All right, a few more properties here. If two inscribed angles intercept the same arc or congruent arcs, then they have to be congruent themselves. So what that's giving you is, here's the inscribed angle that this is referencing, at least one of them. And it creates this angle here. So look at its intercepted arc. Its intercepted arc would run from here to here. All right. Well, if we look at K, so let me try a different color. If we look at angle K, also an inscribed angle. And if you notice, this here to this here intercepts the exact same arc. So this one's kind of self-explanatory. If we have two inscribed angles that create the exact same arc, then these angles here and here would have to be congruent. Okay. The other one is saying if we have two inscribed angles that intercept congruent arcs, so if I were to tell you that arc TM is congruent to arc EX, then what that would guarantee is that the angle here and the angle here would also have to be congruent. All right, I think it's kind of obvious, hopefully not too bad. This one, if an angle is inscribed in a semicircle, so understand what semicircle means. That means we have something drawn right through the radius. An inscribed angle means our point is always on the circle. So you can put your point anywhere on this entire circle. I'm going to put it right here. And then the way we get an inscribed circle is we take this and we're going to go to this end of the semicircle, this end of the semicircle. So if you ever have an inscribed angle, which means our vertex is on the circle, and the angle creates an arc that's half of the circle, all right, so it's a semicircle, what that would always guarantee is this inscribed angle has a degree measure of 90 degrees. Okay, even if I were to draw one, let's say in a different spot here, so I draw over to here and over to here, create an inscribed angle that is also part of your diameter here, means this is a 90-degree angle. There's no way that could not happen. Okay. Last one, if a quadrilateral is inscribed in a circle, so quadrilateral means we have four sides. So let's put a dot here, here. We can put them anywhere. Let's put it over here. So quadrilateral, all four of them are inscribed angles, so they all lie on the circle. Then the opposite angles are supplementary. So what that would mean is, let's say this is 110 degrees. The opposite angle would be this angle. This would have to be 70. All right. So that's what this is saying. These guys here must also add up to be 180 degrees. Supplementary again, quick little refresh, 180 degrees when we add them up. Okay. So let's use some of those properties. All right, it says given the radius of circle D is 9, so from D to A is 9. That would also then mean that D to E is 9, because every radius is 9. And then arc AL, the measure of arc AL, is 60 degrees. So from here to here is 60. What that would tell us is that this is a 30-degree angle. All right. The other thing that we would want to understand is that since this is a semicircle, it's going right through the radius, this inscribed angle here would have to be 90 degrees. So think about the triangle that's formed here to here to here. we have a 30-degree angle, we have a 90-degree angle. So if you remember, triangle angles all add up to be 180. So what that would tell us is this angle up here must be 60 degrees. Before we left, very last thing that we were talking about were 30, 60, 90 triangles. So if you remember that, 30, 60, 90, the side opposite of 30 was x. The side opposite of 60 was that number multiplied by root 3. The hypotenuse was the x multiplied by 2. All right, so, oh, I'm making this too hard, am I? Yeah, we already have this answer, right? We're looking for mark AL here. So that's going to be 60. Sorry. I was making that way too hard. Oh, no, I'm not. We're looking for the perimeter of triangle AEL. Okay, so we're looking for the perimeter of this triangle inside. And what we know is this side is 18. That's your hypotenuse. So if we revisit this, we know for our triangle that our hypotenuse is 18. So let's change this to 18. What that would tell us is this side here would have to be half of that, which is 9. All right, so the opposite 30 side means this is 9. And then we would take our 9, multiply it by root 3. So this would have to be 9 root 3. Add those up. So the 18, the 9, and the 9 root 3 is 27 plus 9 root 3. All right. So again, a lot of stuff going on there. You really got to kind of be able to think and make some connections. Number 5, find A, B, C, D, and E. A couple of these will be pretty quick. It's one of the rules we just talked about. Opposite angles are supplementary. So we know B must be 70 degrees so that the 110 and the 70 will add up to be the 180. So we know B. So we've got that one taken care of. Same with A. That 86 and A better add up to be 180. All right, so if we do that, know that A is 94 degrees, so that if I did 94 plus 86, they add up to be 180. So we have that taken care of. What can we do next here? Let's do... All right, so let me create some space. So let's write these in. So I know, let me get rid of the drawings at least, as I start drawing in some more lines and such. So let's look at what angle C, or what arc C would be. So if I draw this angle here, notice what chord is, or what arc is created between those two. Okay, well, this entire red arc, if we know the angle here is 86, 86 would have to be half of this entire red arc. All right, it's one of our rules. So what that would tell us is the entire red arc would have to be twice as big as 86. All right, so what is 86 times 2? What, 172? Yeah, so the red would have to be 172 degrees from here to here. But we already know that from H to E, that's 89. So from E to M must be 172. Take away the 89 that we already know. That's, we should get this then to be 83 degrees. All right, so that we have C. Similar process with these other ones. So let me create a little bit of space again. So I'm going to erase some of this. So if you need to pause me, pause me. Get rid of that. Oops. All right. Let's try some different colors here. Let's do purple. So similar with M. So let's say I go from M to O, and then from M out to E. Look at the arc that we have created with those. So if we go from those, here is the arc that's created by those two angles. So that's gray. If our angle here is 70, then we know that arc would have to be twice as big. So that big gray arc would have to be 140 degrees. But we already know 89 of it here. So if we subtract, Gray doesn't like to write apparently, 89 from the 140, what that would give us is what? 51 degrees. So that we would then know that the E would have to be 51 degrees. All right. And then D, we can do a little bit easier. We know all the way around a circle has to be 360 degrees. We're only missing this part here. We know all the other measurements of our circle. We only need this. So all we have to do is do 360, subtract the 51, subtract from H to E here, the 89, and then subtract from here to here, the 83. And then once those are all gone, whatever is left has to be the D value that we are still missing. Okay, so let me do that on my calculator real quick. It's actually my phone, which is about ready to die. So hopefully it lasts a little bit longer. Minus 51 minus. All right, and that should be 137 degrees. All right, so D is 137. All right, 6. Angle A we can get pretty quickly. If we look at what angle A is, it's from here to here. From here to here, it's an inscribed angle. A has to be 1/2 of 57 degrees. So if we just did 1/2 of 57, we would find that angle A is 28.5 degrees. All right, I don't know if I can squeeze that in there. Okay, same with C. So if we go from here to here, if we know that this is 79 degrees, angle C would have to be 1/2 of the arc that it's creating, which is the 79. So we do 79 divided by 2. Should get 39.5, so that's our C. One of the things we had talked about earlier, whenever I have a tangent line to our circle, so here is a tangent line, that circle and then where it intersects is always a 90-degree angle. So this whole angle here has got to be 90 degrees from this black one to this black one. Oh, come on. So if this whole angle here is 90 degrees, and we already know what A is, all right, we said A is this 28.5, then angle B, get rid of this here, so come on, angle B, we can get back to it. Would have to be the 90 degrees overall minus the 28.5. All right, that would have to be what angle B would have to be. All right. Just want to make sure. Yeah, 61.5. All right, so angle B, 61.5, and then what are we still missing? D. D should be a nice, short, sweet one. Let me erase some of this so we don't get too congested. This is a central angle drawn from here to here. This angle would have the exact same degree measure as the arc. So angle D is 57 degrees. So it's a short and sweet one. All right. 7. Let's just jump right to that one right away. Here's my central angle. It goes from here to here. It creates this arc. Those have to be equal to each other. So right away we can get that B is 88 degrees. If we wanted to do A then very quickly, so look at angle A. From here to here is angle A. That's an inscribed angle. It's always 1/2 of the arc that it's creating. So if that's 88, angle A would have to be 44. All right, so those hopefully are pretty quick. All right, let me get rid of this. Oops, I want to keep that. I want to get rid of this arc. So we're still missing D. So let me do this in red. We have an inscribed angle where our angle lies on the circle. This angle must be half of the arc. So the arc that it's creating is the 150. So this has to be 75 degrees. Same exact thing is going on with angle C. Angle C is this angle created by those two. This angle has to be half of the arc created there. So here's this arc. So once we know what this arc is, we know C would have to be half of that. So again, we use the idea that a full circle is 360. We know from here to here is 150. So we would subtract 150. That would leave us with 210. From here to here is 88. So we would subtract 88 from that. That's what, to 122, I think. Yeah. And then what that would tell us is E would have to be 122 degrees. And if that's 122, angle C would have to be half of that, which is 61. Okay. All right, what do we got left here? All right, last one. So we'll go through this hopefully fairly quick, put all this together, see if we can do some of these on our own here then. It says measure of arc AB is 10. So this little guy here is a 10. BC is 20. So this arc here is 20. Arc ED is also 20. First, then we're just going to go through, find most all of these things. Okay. So first one I'm going to do, arc AE. If you look, this is a diameter. So we would know from B all the way around to E, this would have to be 180 degrees. If you've noticed though, we already know some of this. This is 10. So if I just wanted to go from A through E, then we would just have 170 degrees left over from A to E. So this would have to be 170 degrees. Okay, so we got that. All right, arc CD. Yeah, so it's another one of the ones where if you look all the way around this circle, so we want from C to D, it's the only arc that we are missing of the full 360. All right, we know this is 20. We know this is 10. We know this is 170. And then we know this is 20. So CD is all we are missing of the 360. So 360 and then subtract the 20 that we have here, the 10 that we have here, the 170 that we have here, and then the 20 that we have here, and all we have left is what we would need for C to D. Okay, so let me throw that in real quick. Minus 20 minus 10 minus. Hold on. Using my phone, not real good with it. 360 minus 20 minus 10 minus 170 minus 20 should be 140. So this would have to equal 140. All right, angle, our arc BAD now. This should be pretty quick. We can just add them all together. So go from B to A to D. So here's B, and then we're going to go to A, and then we're going to go over here to D. So if we did that, B, A, all the way around to D, we just add up all those values. So we would need to add 10, 170, and 20, add all those up, should get 200 degrees. All right. Measure of angle C. So here's angle C. Think about what angle C's intercepted arc would be. Let me just, yeah. So if angle C is from here to here, okay, that's how we created that. So the arc is going to be running from B all the way over here to E. So add B and E together, that would be 180. It's also going to be half of that, 90. Actually, I probably made that one a little too hard because this is one of our little rules where this is basically an inscribed angle that creates a semicircle. This would have to be 90 degrees. Okay, so we could have actually just written that down right away. Measure of our angle BEC. So where's BEC? So that's this angle right here. We know the intercepted arc is 20. This has to be half of that, so that's 10 degrees. Angle D, where is he at? That one I might have a bad problem. I can't see all of this clearly. And then this thing keeps on messing up when I do that. Angle D. Okay, now I can see it. So if we look at that guy all the way through, angle D, there is a line right here, and then to here. So think about that arc. That arc is 170. This has to be half of that, so this has to be 85 degrees. And then measure of angle BED. So BED. It's getting jumbled here. Sorry. BED. Try to erase some of this. Get rid of that. Get rid of that. Draw this in red. So BED would run from B down here to E, up here to, oops, one. BED, so it goes from here to here to here. So if we look at the arc that creates, that would be this here, which is 160 degrees. Half of 160 degrees is 80. So this would have to be 80. All right, so pretty complicated there. Hard to keep track of even as I'm doing this here. A lot of stuff going on there and overlapping, but probably wouldn't necessarily give you like that question on a quiz or something, especially doing this online. So good luck with all that. If you have any questions, let me know. Probably give you a little quiz, and again, quizzes can just help you a little bit. So if those are looking to bump a grade up a little bit, we'd probably do that next week at some point. So anyway, if you have any questions, reach out. Hopefully this made some sense. Don't freak out too much about number 8 with all that's going on there. Just kind of a nice way to wrap up, see if we can put all that stuff together. That's it. Have a good day.